Hello, hi everyone. Welcome to Vedantu JEE English. I'm Diksha Kaushal, your chemistry master teacher. So everybody, do let me know in the chat box if I'm clearly visible and audible to all of you, so that we can start with today's session, that is geometrical and optical isomerism. And yesterday in the last class we have discussed about structural isomerism. So let me just give you a brief about it. That we have already discussed about structural isomerism, tautomerism, everything, right? Now in today's lecture, till yesterday we have done cis trans, which will show GI or not, all these things we have done, and I also gave you homework based on that. So let us see what was the homework, everybody. Let's see the homework here, right? So this was the question that I gave you for your homework, right? Okay. Now, here D is going to be the correct answer. The question was identify the correct statements from the following. So, these are the statements here. 1 and 2 are metaphors for each other. That is true, right? Then this and this are functional isomerism. That is also true. This and this are position isomers. So, this is 1, 2, 3, 4, 5. This is 1, 2, 3, 4. Wait a minute. This is 1, 2, 3, 4 carbons. This is 1, 2, 3, 4, 5. So, they are not even isomers, right? They are not even isomers of each other. So, definitely this is not the correct statement. This and this are homologues, right? So, this is 1 degree amine. If you see, this is 1, 2, 3, 4 and this is 1, 2, 3, 4, 5, right? And this is 2 degree, right? If you see, this is 2 degree. So, definitely 1 degree, 2 degree are considered as two different functional groups. 1 degree, 2 degree amine are considered as two different functional groups. 1 degree, 2 degree, 3 degree are different, right? So, that is the reason this is also not true. So, answer will be D is the correct answer, that is A and B is the correct statement here, right? Okay, everybody, do let me know if that is clear to all of you or not, right? Yes, everyone, do let me know if that is clear to all of you or not. Just give me a second. I think the camera angle is a little bit. Just give me a second. Okay. I think I surely cannot resolve it at this point. So, it's fine. Right? Okay, everyone. Yes. So, that was your homework, right, that I gave you, right? And this is what I am saying again and again, and start doing your homework, right? It will help you to practice questions and to remember the questions when the time is needed, right? And for practicing questions and the things that you are learning, you can also apply it in the MVSAT scholarship program, that is registrations are almost towards the end because not even 10 days now are left for the MVSAT offline test, that is 4th, 5th, 11th and 12th of October. Now in this particular thing, what we are going to do is, right, if you first see no registration fees is there, and after that if you get into 2.5 lakh students, then you will get 150 crore worth of scholarship, that is 100% scholarship on the Vedantu courses, and 2 crore worth cash prizes and some rewards like iPhone, iPads, drones, all these things you will get, right? So, what you have to do is you just have to register yourself and then give this exam, right? Rest of the things, and for JEE only 45 questions will be asked, 15 chemistry, 15 maths, 15 physics, that's it, right? So, you're already preparing for that, so it's better to grab the opportunity, right? Okay, yes. So, now guys, let's discuss, right, about isomerism. It was divided into two parts, one is structural, then there is stereo. Structural isomerism is also called as constitutional, and all these isomerism we have discussed in the first lecture of isomerism, right, that is yesterday. Now here we have stereoisomers. In stereoisomers, it is further divided into two parts. One is configurational, other is conformational, right? Conformational isomers we will do in the next class, and today we are going to talk about geometrical and optical isomers. That is, this part we are going to complete in today's lecture. So let's start with it. Yes, everybody. Hello, Jasveer, Abhishek, Anuradha, Guru, Vidya, Deepa, Adil. Hello. So let's start with the session, right? Let's start with geometrical isomerism. Till geometrical isomerism, I'll just recap this. What was geometrical isomerism? We discussed that this exists in alkenes where this is 1, this is 2, this is 3 and this is 4. Then one group should not be equal to 2 and third should not be equals to 4. That means on the same carbon you should have two different groups, only then GI will exist, right? Now when we say GI will exist, right, according to that, if you see it in alkene, that shows restricted rotation, right? This is how it is going to exist. On one carbon, two opposite groups should be there, right? And if I talk about in case of cycloalkanes, also GI exists, right? But in this case, what we do is, the trick is same substituent on different position. That means on different positions, that means on same substituent. If we have same substituent on the same position, then GI will not exist. For example, here you have on the same position, you have two same substituents, so GI will not exist in this case, right? Once you know about whether GI exists or not, I told you about cis and trans isomers, right? That if two same groups are like side by side, it will be called as cis. And if two same groups are opposite to each other, that is called as trans. Then the last part we also discussed about the properties of cis and trans, like trans has less dipole moment, cis has more dipole moment, trans has more melting point, trans has more stability, right? All these things we discussed in the last class. Now, in the geometrical isomerism, next category is defining Z and E, right? These are also geometrical isomers, but here we are going to define Z and E. But before that, let me know if there is any problem in the previous session. If there is no problem, then hit that smash button, hit the like button, so that even I can get motivated, even I can, because homework though, now I am like, when these students will start doing their homework, like literally I'm waiting for like 3 months, like there's no unity. Only few students do their homework, and trust me, they will get benefited out of that, right? But if you're like, ma'am, yes, we are able to understand from your lectures, then hit that like button. That motivates me, right, to do more for you, right? Okay, so now let's talk about Z and E, right? Now Z is Zusammen, that means same, right? And E means antigenal, that means opposite. Now this, what does it mean? What is the name? That you don't have to remember. Just remember, Z means same side, E means opposite, right? How you can remember this? Just remember this by E enemy. Okay, enemy is always on opposite side or enemy is on your same side. If you have an enemy, right, he will be on the opposite side, he or she will be on the opposite side. So enemy always on the opposite side. Now ma'am, opposite side we had trans, right? But just imagine that you have a compound in which all the 4 groups are different, right? Then how will you tell that whether it's cis or trans? You can't define it. When all the 4 groups are different, right, then we will use E and Z, right? Let's define that, right? First is to answer whether it's E and Z. This will also use in RS configuration, right? To define it, first you need to understand what is CIP, right? What is CIP rule? So CIP rule is to give the priority, okay? What we do this? To give priority. Now this is a very important thing that I'm going to start. To give priority to atoms or group of atoms. Atoms or group of atoms. Group of atoms, right? This will be very useful in further RS configuration as well, right? Okay, this is to give priority to group of atoms or atoms, right? So with the help of example only you will be able to understand this. I am not going to show you some rules and then go. I'll not even show you firstly rules and then give you the examples. I'll just give you examples. With the help of examples, I'll give you the rules, right? So that with application part, you can understand that how you can remember this, because in competitive exam, they are not going to ask what is CIP rule. You have to understand how to apply that rule, okay? So CIP rule, simple two things are there, that more atomic number will get higher priority. Higher priority means 1. Lower priority is 2, okay? Some students also get confused here. Higher priority is 1. Lower priority is 2. Okay? So, more atomic number will get higher priority, that means 1. In case of isotopes which have same atomic number, more the atomic mass, it will get higher priority, that means 1. Okay? Just these two rules you have to remember, and almost all our questions will be based on these rules only, right? So I'll start with some very basic questions here, right? So in this case, see, you can't define. If someone asks you, okay, is this GI? Yes, on same carbon you have different groups. On same carbon you have different groups. So this is definitely GI, right? But if I ask you, is this cis or trans? Then you can't define whether it's cis and trans. Why? Because all the 4 groups are different here. So there is a new thing that we will define here, that is EZ geometrical isomers, right? Now how do we define it? On first carbon, this carbon, you will have 1-2 priority. Here also you will have 1-2 priority. Okay, let's firstly give the priority. Okay, here also remember that 1 atom at a time, right? Atomic number means, if I go here, I'll meet chlorine. If I go here, this is actually, I'll meet carbon firstly. Hydrogens are just attached to this carbon. So you just have to go one step at a time. You just have to see the next atom. Don't see next to next atom. That you have nothing to do with. Nothing to do with, right? Even if this whole group of atom has more atomic number or atomic mass as compared to this one, you have nothing to do with that. You just talk about the first atom that you meet. Here the first atom that you meet is chlorine. Here first atom that you meet is carbon. This chlorine has more atomic number as compared to carbon. So that is why this will have first priority, this will have second priority. Now if you see this here, this is nitrogen, this is hydrogen. Here you will meet nitrogen, here you will meet hydrogen. Okay, both are different, right? Now guys, this is class 11th or class 12th. It's class 11 guys. This will be useful in class 12th also. But if you are doing it class wise, then this is class 11th. Okay, isomerism in class 11th, right? Okay, yes, let's do this. So here if you see, nitrogen and hydrogen, which will have always, hydrogen will be least priority because atomic number of hydrogen is always less as compared to any other atom here, right? So this is first priority, this is second priority. Now guys, can you see 1, 1, this is 2, 2. That means you have 1, 1 same, 2, 2 same. Same means it will have configuration Z, okay? 1, 1, 2, 2 means it has same on both sides, right? That means configuration will be Z here, right? So this is going to have Z configuration. Let's talk about the next question here, that is this one. But do let me know if the first one was clear to all of you or not, right? Okay, yes. Was it clear? 86% of you take notes during the class. That's awesome, awesome, awesome. Very nice. Very happy to know that. And let us also see how many likes you have given, right? Just 14 likes you have made it till now. That's such a shame, guys. Such a shame, right? Not done, huh? Not done. Not done. Right? Chalo. Not done. I'll see after 10 minutes, I'll again see how many likes you have given, right? Now on this particular carbon, if you see, this is the chlorine that you're meeting, this is hydrogen that you're meeting. So definitely chlorine has more atomic number. So here priority will be 1, this priority will be 2, right? In this case, if I want to elaborate it and write it, how do I write it? I can write it as something like this. This will be, I'll tell you why we are writing it like this. So if you see this here, this will be H, 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 H and H. But what you're meeting here for the first time, you're meeting just carbon here. Here also you're meeting just carbon. Now see one thing, this is the second rule. This is the second rule that you need to remember here. This is the second rule that you need to remember. That if the first atom that you meet is same, if the first atom that you meet is same, the first atom that you meet is same, cancel this atom. Because that is the same thing, you cannot differentiate it which will have more priority. If the first atom that you meet is same, you will see that now how I am going to write it, right, to make it more simple for you. This carbon here is connected to 2 hydrogens and 1 carbon. This is how you are going to draw it so that you don't do any mistake, okay. This carbon is connected to 3 hydrogens, right. This is what you need to learn in today's class, and these things you can't learn it simply from books. You need a teacher to tell you that to simplify it, right. Obviously you can learn it from books as well, right, but it will be more simpler if a teacher is there for you. CC will be cancelled, HH on the second go will be cancelled, HH will be cancelled. What you are left with now, the differentiating part is this is hydrogen, this is carbon. That is the differentiating part. Other things, just don't just cancel it like this, C, C, H, H. Do it like this. I'm telling you why to do this, right? Because when you go beyond that, there will be double bond, there will be triple bond also. That's why I'm telling you, this way if you do it, you will never do any mistake, right? I'm also going to show you some very complicated structures here so that you are able to answer there as well. Right? EZ configuration, if they ask you, the structure will be very nice, right? It's not like these kind of simple structures they will ask you, they are going to ask you really good structures, right? Now if you see this here, this is C, this is H, which has more priority. Obviously C has more priority, so this will be 1, this will be 2, right? So what we are going to say, this is 1, 1, 2, 2, this is 1 opposite 1, 2 opposite 2, that means it is a Z configuration, right? That means it is a Z configuration. Is that clear? Yes, OC, right? Most probably, right? Most probably I will finish it only, right? Maybe 2-3 days more it will take, but not more than that. Because GOC part is what I teach students like in too much detail. Otherwise, the rest of the part is more about reactions, and that is mostly repeated again and again, right? So don't worry about it, that we can easily do, right? Okay, yes. Right everyone, got it? So here it is going to be Z configuration. Next guys, what we have here, now let's see this also. In this case here, this is hydrogen isotope, right? So more the atomic mass, more is going to be the priority. So this will have first priority, this will have second priority. What about this one, ma'am? What about this one? So can I say this, I have met carbon, here also this is carbon, I will cancel this. So this will be C, this will be H, H, this will be O18. I am not going to write that after this also you will have H. I am not writing that, there is no need of that. Here you have C, this is H, this is H, this is O16. Now if you see one thing, CC will cancel, HH will cancel, you will have O18 and O16 as a differentiating factor, right? Now this is O18, this is O16, tell me, this is the isotope of oxygen, Which has more atomic mass? O18 has more. So this will be 1, this will be 2. Again, no, now you have opposite here, right? Now you have opposite. 2, 1, and here you have 1, 2. So can you see opposite 2, 1, 1, 2? So that means it's a E. It's a E here. Right everyone? So it's a E here. So we'll write E is the correct answer. Now this one is something, right, that is going to make things even more clear, right? But before doing this, tell me in the chat box if you have any problem before, like if you have any problem here, then understanding this will be beyond your scope, right? If you have no problem here, then the next one will be very simple for you, right? So I have set the examples according to that only, right? The examples are like that only, something are very basic, then little bit on the higher side, right? Okay everyone? Yes. Yes students, do let me know in the chat box if there is any problem till here. If there is any problem till here, do let me know in the chat box, right? If there is no problem, then smash the chat box with green hearts. Smash the chat box with green hearts. Yes everyone? Okay, perfect. Now let's see this here. Okay, so firstly I'll talk about this case, okay? Here also you're meeting carbon, 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 carbon. So I'm going to tell you one very interesting thing here. If you have C triple bond C, that means C is connected to C 3 times. If you have C double bond C, that means C is connected to C 2 times. If you have C single bond, that means single only. If you have C double bond O, that means C is connected to O 2 times, right? Okay, this is how you are going to look into these kind of double bonds and triple bonds, right? Okay, yes. Ma'am, please explain isotopes. Students, isotope, you want me to explain what are isotope? Isotope which has more atomic mass, hydrogen, deuterium, tritium. Tritium has more atomic mass, so it will get the first priority. Here oxygen has more atomic mass, oxygen 18 has more atomic mass, so it will get the more priority, right? Okay, yes. Okay, now see this, okay, tell me if this thing is clear. C triple bond C means C is connected to C 3 times. C double bond means C is connected to C 2 times. C double bond O means C is connected to O 2 times, right? Is this thing clear to everyone? Tell me, so that I can define what is written here. Okay, now I'll mark this A, B, C, D so that you understand. Let's say this is A carbon, let's say this is B carbon, let's say this is C carbon, let's say this is D carbon. Or we can also define it as A, B, C, D only, right? In case of this carbon here, in case of carbon number A, it is C double bond O, right? It is C double bond O, it is one H here and it is connected to one H. That means this carbon is connected to 2 oxygen and 1 H. In case of B, it is connected to 2 hydrogens and 1 carbon, 2 hydrogens and 1 oxygen, right? So here, instead of writing CH2O, I'll write it as carbon is connected to 2 hydrogens and 1 oxygen. Okay, this you have to be clear with. This hydrogen is attached to the oxygen, that I am not thinking about, right? I am just thinking about this carbon is connected to which thing, how many things. This carbon is connected to 3 carbons, okay? So C carbon is connected to, this is C triple bond C, C is connected to 3 carbons, okay? D, this carbon is connected to C double bond and this hydrogen. That means this is actually C double bond, this is CH and C, this is nothing but this is CH double bond, something like this, okay? This thing, right? This is a connection, right? So that means this carbon is connected to 2C and 1 hydrogen, okay, right? Now what we have to do is we have to compare A and B, Because A and B are on the same side, A and B are on the same side, I need to find the priority of A and B. So how I will find? Carbon, carbon I will cancel, hydrogen, hydrogen I will cancel, oxygen, oxygen I will cancel, and you are left with one oxygen here and one hydrogen. Tell me which will have more priority. Oxygen will have more priority as compared to hydrogen because of more atomic number. So that's why you have CHO bond will have more priority as compared to CH2OH bond, right? Okay, either you remember all the groups which have more priority, either you do it this way, right? I always prefer this way only because sometimes they ask you some different structures also. So if you do this way, better, right? Here between this and this, carbon, carbon cancel, right? Carbon, carbon cancel, carbon, carbon cancel, carbon and hydrogen you are left with. So this carbon will have more priority as compared to this. Now I will just write it. This will have more priority as compared to this, and here this will have more priority as compared to this. So we can say 1, 1, 2, 2, that means it's a Z configuration, right? Okay everyone, do let me know if that is clear to all of you or not. Right students, do let me know if this particular thing is clear to all of you or not. What we are doing is EZ configuration based on single bond, double bonds. This is how we are going to do it, right? Okay, this is Z, definitely, that is correct Abhishek. Very good, very good, very good. Now let's talk about some more questions here, right? Okay, this one, right? Let's talk about this one. If you see this here, it's very simple. It's kind of simple only. You can tell me this. Everybody comment it in the chat box. In the chat box, write it down. What is the correct answer for this one? This is quite simple. Here you have fluorine. Here you have carbon as the first one. Here you have carbon. Wait a minute. This is actually trans. Chalo. In EZ also tell me what it is. In EZ also tell me what it is. It's trans. In cis and trans it's trans, but in EZ also tell me what it is, right? Okay, yes everybody. So here what you have, Z, Abhishek is saying Z ma'am. Okay, what about others? Matthew is saying Z. What about others? What about others? RDC is saying Z. Okay, great. So what we have here is, this is the first priority, this is second. Fluorine has more atomic number. Out of carbon and hydrogen, carbon has more atomic number. So we can clearly see 1, 1, 2, 2 means Z configuration it has. Okay, right? Okay, wait a minute guys. Now I'm going to draw some really interesting structures for you. Right, wait a minute. Let me just do that. Just give me a second. I'll just do that. Okay. Yes. Right. Let's do that. Okay. So let's say there is a structure. Let's see. C double bond. This is 1, 2, 3, 4. Let's say here you have this kind of situation. Okay. And here you have this kind of situation. Okay, let's say here also you have this kind of situation. Okay, yes, right. This is CHO and this is CH2OH. Okay. Now tell me which will be the correct answer here. Let's see if you can find that or not. Ma'am, live is up to, live will take some time. Now so we have just started. It will take some time, right? Completing isomerism is a tough task, right? So it will take some time, right? Not like 10, 15 something, right? After that I'll end the class. Now if you see this here, out of this we have already discussed about this, that this carbon is actually connected to C double bond OH. and this is actually connected to CH, H, and this is OH. That means carbon, carbon, this is connected to 2 oxygen, this is connected to 1 oxygen, so this will have more priority. This is COOH, this is CHHO. So definitely it will have more priority. Now what about this one? What about this one? This you have to discuss here, right? What about this one? If I want to discuss this one here, this particular carbon here is connected to 1 carbon and 1 carbon. This particular carbon here is connected to 1 carbon and 1 oxygen. So because this carbon is connected to 1 carbon and 1 oxygen here, so that is the reason this will have more priority as compared to this one. Got it now? This carbon is connected to 1 carbon, another carbon, there will be 1 hydrogen here. This carbon is connected to 1 carbon, another oxygen, and 1 hydrogen. So obviously when you cancel it, carbon, carbon, hydrogen, hydrogen, this is carbon, this is oxygen. So this will have more priority as compared to this one. So that is the reason this will be the sequence, and when you draw it, this is 2, 1, 1, 2. So that is why it's a E configuration, right? Okay everyone, do let me know in the chat box if that is clear to all of you. Right? That's why I told you that don't just cram CHO, CH2. Sometimes these things are given to you, for that you need to understand how connectivity you are going to see, right? Okay everybody, got it? Easy peasy. Shall I give you one more question? Will you answer that? Tell me. If you will answer only, then I'll give, otherwise I'll jump to the next topic, right? If you're like, ma'am, yes, we will answer, tell us, ma'am. If you're like full energy is there, right, then only I will give you the question, okay? Otherwise I'll move ahead. Right? Okay. Tell me. Right everybody? If you want, then only I will draw some structure here. Right? Let me see. Of course, ma'am. Okay. Let's see. Okay. So I am giving you 2 structures here. Let me just firstly make it in my mind. Okay. So let's say you have this structure and you have this structure, okay? And please just don't say more number of carbons and all these things will not apply, right? Maybe or maybe not, right? Here let's say here you have okay, and here you have CHO. Okay, let's do this. So one question this is I am giving you. Let's see whether it's E and Z. Let's see whether it's E and Z, right? Let's see that. Firstly, for this I'll define by the time you answer. This we know that this particular carbon here, it is connected to 2 more carbons and 1 hydrogen. This carbon here is connected to 2 oxygens and 1 hydrogen. So definitely what will happen, carbon carbon cancel, hydrogen hydrogen cancel, here you have 2 carbon, here you have 2 hydrogens. So definitely this is going to be more priority as compared to this one. Now you can't do anything with this 1 and 2 if you have no idea on this one, right? So let's understand what we are going to do here, right? So one by one we'll see. Sometimes students just cram that more the number of carbons, more. Sometimes it is true, sometimes it is also not true. So that's why I'm telling you, do what I'm telling you, like with that simple steps only you will follow. So this carbon here, this carbon is connected to 2 carbons, okay, and 1 hydrogen, okay. So this carbon is connected to 2 carbons and 1 hydrogen. This carbon here is also connected to 2 carbons and 1 hydrogen. So the 2 carbons that you have here, that is also connected to further 1 carbon, right? Right, this carbon is connected to 2 hydrogens and 1 carbon. This carbon is also connected to 2 hydrogens and further carbon, 2 hydrogens and further carbon, right? Okay, right? And they are making a cycle with each other. If you see this one, this carbon is connected to this carbon, which is further connected to this carbon, because now here till here it is stopped. Till here there is no other carbon that you have. You have included, say this carbon is connected to this carbon only. Wait a minute, let me just show you that. This carbon is connected to this carbon which you have already included here, right? So that means they are interconnected here, right? And others were these hydrogens only, right? In this case, when you talk about these 2 carbons, they are further connected to 1 more carbon here, right? Okay, that means clearly what we can see in this case, right? This carbon is cancelled, this will cancel each other, right? But what will happen here, further more carbons you will not see. Here further there is 1 extra carbon that you have. That is the reason that we will give more priority to this one rather than this one. Okay, understood? But you always have to see that if there is any oxygen, if I draw 1 oxygen, let's say if I draw 1 oxygen here, then that will have more priority, right? Let's say here it is, this is more priority, right? Let's say if I draw 1 oxygen here, right? Sometimes students, they just cram this thing. They just cram this thing that more the number of carbons, more will be the priority. But if you have less, here you have less number of carbon, but here you have oxygen. Now you will see the difference. Now if you see here what you will have, this carbon is connected to 1 carbon and 1 oxygen and 1 hydrogen. This carbon is connected to 1 carbon and then 1 hydrogen. So can you see here, hydrogen will cancel, carbon will cancel, carbon and oxygen is a differentiating point. So even though it has less number of carbons in overall ring, but that has more priority. Okay, so don't just cram that number of carbons, more the priority, no, right? You have to see whether there is some oxygen or nitrogen also there, right? Yes, if there is no oxygen or nitrogen, then you can say more the number of carbons, more will be the priority of that ring. But if in that ring you have any hydrogen, any oxygen or nitrogen, then that will have more priority. Okay, yes everybody, do let me know in the chat box if that is clear to all of you or not. Right everyone? So let's see this here, So this will be 1, 2, 2, 1, that means E will be the configuration in this case, right? Okay. Now next is anti and syn. And this reaction you will do in aldehyde ketones and carboxylic acid, will do it majorly. So basically ketones, when they react with derivatives of ammonia, then H2O will be eliminated and you will have CRH. If aldehyde is there, so it will be H here, this will be double bond N and OH, right? There will be 1 lone pair over here. And if you have ketoxime will be formed from ketone, again water will be eliminated from here, right? And hence you will have C, this is R dash, right? This particular reaction we are going to do in aldehyde and ketone, well, when we will do that, right? Here I have just shown you that, okay, this is how aldoxime, this is aldoxime and this is ketoxime. Basically these are oximes. If oxime is made from ketone, that is ketoxime. If it is made from aldehyde, that is called aldoxime, right? Okay. Now in these cases we see anti or syn, right? So anti and syn is related to OH and H. If OH and H, they are on the, oh my god, what is happening these days? Okay. If OH and H, just give me a second. OH and H, they are on the same side, then that is called as syn, right? And if OH and H are on the anti-opposite side, that is called as anti. What do you mean by anti? Anti means opposite. So here we are discussing about H and OH. If they are on the same side, that is syn. If they are on the opposite side, that is called anti. But the question is, ma'am, in aldoxyme you can tell because you have hydrogen here. But ma'am, what about ketoxyme? In ketoxyme, how will you tell that whether it's syn or anti? Because there is no hydrogen here, which is opposite, right? So in this case, we'll define it according to the alkyl group, right? If you talk about with respect to methyl, this is anti. But with respect to ethyl, this is syn. So it depends upon with which respect you are talking about. If you are talking about OH with respect to CH3 is anti, OH with respect to C2H5 is syn, right? So syn means with respect to OH we are checking whether it's on the same side or on the opposite side. Okay, everybody, is that clear? Is that clear, students? Is that clear? Tell me if there is any problem here, because now we are going to see and calculate number of geometrical isomers, right? Now we are going to calculate number of geometrical isomers. If there is any problem, then do let me know in the chat box, everybody. If there is any problem, do let me know in the chat box, right? So that we can start with the calculations of geometrical isomers, right? It's as simple, right? Really, it's very simple, and very frequently, even in JEE 2025, a lot of questions were asked based on calculation of stereoisomers, GI, right? So that's why this is like one of the most important topics, that is calculation of isomers, right? You know, in calculation of isomers, my part is quite easy because I just have to tell you the formula. That's, let's be very frank, right? Your part is little tough because the formulas of geometrical isomer, optical and stereoisomer is quite similar. So they can get very confusing, right? So that's why in today's class only I am going to discuss all the kind of calculation of the formulas, right? Okay. So first thing I'll discuss about geometrical isomers, right? So let's discuss how to calculate the number of geometrical isomers, right? So these are the formulas. Now formulas is very simple, you just have to apply the formula, right? But what is this N? N is the number of geometrical isomer sites. That means you need to have a double bond. That means you need to have a double bond with one carbon, each carbon has different substituent. What was the condition of GI? That you need to have a double bond. If you find a double bond and here you have opposite, 1 and 2 are opposite, 3 and 4 are opposite, then we can say that that is a geometrical isomerism site. Okay. Now if it is asymmetrical, then the question is very easy. And till now they have asked in PYQs asymmetrical only, but they ask symmetrical also. Right? If it is asymmetrical, that means there is no plane of symmetry there, then you will say it is 2 raised to power n. But if it is a symmetrical structure, then it will be 2 raised to power n minus 1 plus 2 raised to power p minus 1, where p is n by 2 and p is n plus 1 by 2 if n is odd or n is even. Right? Okay, everybody, got it? Basically, you have to divide it by 2. If it is even, directly divided by 2. If it is odd, add 1 and then divide it by 2. 2 raised to power n minus 1, 2 raised to power p minus 1 is the formula. Right? Now, this you can only understand by some examples, right? So, let's see the examples here. Now, here you have to tell me how many geometrical isomerism sites that you have. So, if you see the geometrical isomerism sites here, this is the double bond, this is the double bond where this H is different, CH3 is different. That means two different groups. H is different, this whole group is different. That means two different groups. So this is a GI site. What about this one? On this carbon, you have two hydrogens that are here. That means on one carbon of the double bond, you have same groups. That means this is not a condition of GI. So number of GI sites is 1, right? And is it a symmetrical or asymmetrical? We can see this is not a symmetrical structure, right? If you pass a plane from here, this is not a mirror image, right? That is not symmetrical, right? So we can say for unsymmetrical, the answer is GI is 2 raised to power n. So that means 2 raised to power 1. So answer will be 2 is the correct answer here. Is that clear, everybody? 2 is the correct answer here. Tell me if you have any problem over here. Tell me guys if you have any problem over here. Any problem over here. Right? Yes, students. Now let's see this. Let's see this. Next is, in this case, how many GI sites you have? This is the GI site. H is different, CH3 is different, H is different, this whole part is different. This is also GI site because H is different, CH3 is different, H is different, this whole part is different. So number of GI sites is 2, right? Number of geometrical isomerism sites is 2. Guys, please stop like talking nonsense with each other, right? Okay, let's focus here, right? Who will tell you that no, this chit chat is going to give you nothing in your life? It will give you this in your life, right? So focus on your career. All these people will fade away and nobody will be there, right? They are not going to give you, they are not Ambanis who can give you jobs. Hey, don't worry, be my friend, take this job. Take a chill pill. They themselves will ruin their career as well, yours as well, right? So it's your choice what you want to do. If you are here, then study. And trust me, if you don't want to study, go and watch some good movies or something and go out. At least do something, right? If you are there and you are like listening to me, you are already ruining it, right? You are already like ruining your fun, right? Because you are listening here, you are studying, and for that also you're not studying, you're chit-chatting. That means better are those persons who are not studying only, who have given up. Because at least they are not in that illusion that I was there in Diksha Ma'am's class, right? If you are there in the class, be attentive in the class. Otherwise, there is no use of giving yourself false hopes that I was there in the class, still I was not able to understand, because you were not totally present, you were chit-chatting with your mates here, right? So that is a biggest illusion that you are giving yourself, right? So n is 2 here. Now tell me, is this symmetrical or asymmetrical, guys? Is this symmetrical or asymmetrical? Can you see CH3, CH3, yes, CH, CH, yes, CH, CH, yes, right? That means this is a symmetrical structure. Can you see this is a symmetrical structure? If you have a symmetrical structure, then what you are going to do here? In a symmetrical structure, directly say what is P, because this is even, so it will be 2 by 2, that is 1. And the GI is going to be 2 raised to power n minus 1 plus 2 raised to power p minus 1. So here it is going to be 2 raised to power n minus 1. N is 2. So 2 minus 1. This is 2 raised to power 1 minus 1. That is going to be 2 raised to power 1 plus 2 raised to power 0. 2 raised to power 0 is nothing 1. So it is 2 plus 1. That is 3. So answer is going to be, number of GI are going to be, geometrical isomers are going to be 3. Number of calculations, we are doing the calculation of GI here. Number of geometrical isomers are going to be 3, right? Okay, P is equals to n by 2. Very good, Abhishek, very good, right? What about double bonds? From these double bonds only we have picked, no? From these double bonds only we have picked, right? That this double bond is the center of GI. This double bond is the center of GI. GI is what we have studied in GI. There were double bonds. That's how we discussed GI, right? So these double bonds are going to define whether it's a state of GI or not. Right? Okay. Yes. Now, let's do some questions on that. Right? These are your PYQs where they are asking you the geometrical isomer. This is JEE 2024 question. Right? Number of geometrical isomers possible for the given structure are how many? Right? Okay. Firstly, guys, if you see this particular, both are different, this is a GI site. If you see this also, both are different, this is also a GI site. Wait a minute, let me see if it is different or not. This double bond here, CH2, CH2, then double bond, CH2, CH2. Then you have a double bond, right? Wait a minute. This double bond is connected to methyl, methyl, right? Then this double bond is connected to DH, DH. Okay, so these two compounds are same only. This is not a GI site. This is not a GI site. Why? Because this double bond is connected to the same thing here. It is connected to the same thing here, right? So this is not a GI site. What about this one? These two are different, so this is also a GI site. So that means number of GI sites are 2. Tell me, number of GI sites are 2 here. Are you able to see that, right? Because if you see this one here, if you're also counting this in GI site, then see this. Here, this is one CH1, this CH2. Then there is one this bond, this bond. Then there is one double bond, Then there is one D. Then there is one H here, one CH3, one CH3, right? Then there is one H here, one H here. Can you see that both the things are same only, right? So how they have confused you? So that in hurry you write, okay, this is also a site of GI, right? But in reality, these two groups are same only, right? Okay. Yes, everybody. But now, can I say this is a symmetrical structure or it's a symmetrical structure, right? Yes, this is a asymmetrical structure, right? Okay. So 2 raised to power 2, it should be 4, right? So total number of geometrical isomers are 4. Now I know you will see, ma'am, 3 stereo centers, symmetrical stereo centers. Now at this point, don't look at the stereo centers, okay? At this point, don't look at the stereo centers, nothing, right? Just look at this thing here, that this is a asymmetrical molecule which will have 2 raised to power n, that is going to be 2 raised to power 2, okay, that is 4. So number of GI sites is going to be 4 is the correct answer here. Right, everybody? Got it? Yes. Next one is this, so you delete only, right? Directly say 2 raised to power 2, that is 4 is the correct answer here. Okay, everyone? Do let me know if that is clear to all of you or not. Yes, everybody? Do let me know if that is clear to all of you or not, so that we can start with the next part here. Right, everybody? Do let me know if that is clear, so that we can start with the next part here. Right, students? But a stereo center we are going to do, for that in the end we will do stereo center, okay? Let's ignore that now, okay? So optical isomers, let's discuss about optical isomers, everyone. Let's discuss about optical isomers, right? So optical isomers are basically, what you have a plain unpolarized light, okay? Now you make it a plain polarized light, right? Now when you have a plain polarized light, right, by passing it through a Nicol prism, you make it a plane polarized light. Now this plane polarized light is passed through a compound. This plane polarized light is passed through a compound. Now if passing through that compound, this plane polarized light is rotated towards right or rotated towards left, or it has no rotation, will define the optical activity. If it is rotated towards right, it is called as dextro-rotatory. If it is rotated towards left, it is called levo-rotatory. If it is no rotation, that means it is optically inactive compound. And the ones that get rotated is optically active compounds. Okay, that is defined as optically active compounds, right? Okay, everybody, do let me know if that is clear. You have two things. You have a plane polarized light. If you pass it through a compound, either it will be on the right side or on the left side, or there will be no rotation. If it is rotated, that means it is optically active. If there is no rotation, that means it is optically inactive compound, right? Now, if you talk about optically inactive, now ma'am, always we can't use a compound and go through the rotation and everything. We can't do always, right? So what you will do here, first thing is optical isomer will be, if there is no rotation, it is inactive. Rotation means clockwise means dextro, and levo means it is levo. Levo means it is left side. Okay. So how you can remember it? By dr, right? D for dextro, R means on the right side. That's how you can remember this. But it's not like always you will see the compound and pass it through the prism, the unpolarized light, and pass it through the compound. Then you will see where is the rotation. Then you will check whether it's optically active or inactive. If you want to solve it in theory, there are some points that the scientists have given us, right? Based on so many experiments, the conclusion that they have drawn is this one. That if you see optically active compound, small d and small l we can't define, but we can define whether it's optically active or it's optically inactive. So for optically active compound, first thing is there should be no symmetry in that compound, right? No plane of symmetry, no center of symmetry, nothing should be there. At least one chiral carbon should be there. Then we can say this is an optically active compound. Optically inactive means when the symmetry, plane of symmetry, or any kind of symmetry is there in the compound and all are chiral. Okay, wait a minute. It's not all are chiral, it's a chiral. Right? Okay, wait a minute. And this should be a chiral. Okay? This should be a chiral. Right? This should be a chiral. Right, everyone? So two things are there. One is at least one chiral should be there. Right here, it should be a chiral carbon. Now the question is, ma'am, how will I test the symmetry? How will I define the plane of symmetry? Ma'am, how will I define whether it's a chiral or a chiral molecule, right? For that, individually, firstly we'll talk about plane of symmetry, then we'll talk about the chirality here, right? So firstly, let's discuss the symmetry here. Guys, in our syllabus, we have only plane of symmetry and center of symmetry. These two things we are not going to see, right? Okay. So let's discuss about plane of symmetry. So plane of symmetry means when you can pass a plane which can divide it into equal halves. For example, if I talk about this phone here, right? Or let's say, why we are talking about a phone, let's talk about something more interesting. Right? If I talk about this particular molecule here, right? If I pass a plane from here, I can divide it into equal half. If I pass a plane from here, I can divide it into equal half, right? So, if you remember, we used to do this in coordination chemistry also. So, same things we are going to do here, right? So, this is going to be very interesting. All you have to do is imagine that, okay? Okay, yes. So here if you can see, there is one plane that can pass like that, one plane that can pass like that, one plane that can pass like that. That will divide it into equal halves, right? Then here also you can see there can be one plane that can pass here and divide it into equal halves. So these are some general simple things. Here also you can pass a plane like this which can divide it into equal half. You can pass a plane like this which can divide it into equal halves, right? So that is your plane of symmetry. Now let's talk about these compounds, right, that they can ask you which of the following possess plane of symmetry or not. Let's talk about these things here, right? Okay, let's talk about these things here. Which of the following will have plane of symmetry, which of the following will not have. Guys, now here now what I'll do, see one thing. On one atom only, you have two things, right? Let's say this is a triangle, this here is a triangle, right? And here you have these two atoms, okay? Tell me, can you pass a plane of symmetry here? If you pass a plane of symmetry like this, then it is not plane of symmetry, right? Because it is not divided into equal half. This is grey, this is red. But if you pass a plane like this from this angle, if you pass a plane like this, right? So it will divide it into equal half. These two atom equal half, these two atom equal half. So here it will possess plane of symmetry, which will divide these two atoms into equal halves, right? Similarly, here you will possess an atom, a plane of symmetry, which will divide these two into equal half. Here you can have two plane of symmetry if you have both of them are same, right? If I say both of them are same, right? Okay. Show optical activity. Can you? To chiral center, where is not, even though chiral centers are present. Darwin will talk about those kind of compounds, okay? We'll talk about that, right? Okay. Now, if you have this, you pass a plane from here, it is divided into equal half, so POS is present. You pass a plane from here, it is divided into equal half, POS is present. So we can say POS is present, like definitely here also it is present, and here also it is the same case as first one. So in all of these, POS is present here, right? Now let's talk about this one, right? Now we are not talking about on the same side, we are talking about on the different carbons. If you pass a plane like this, definitely it is a plane of symmetry. But in this case, right, let's say this is the, wait a minute, two Br are same now. Let's say this is the length of that cyclopropane that you have. One you have here, right? Let me just have a very simple bond here, right? Okay. One you have here, other you have here, right? Wait a minute. Chalo, imaginary only, let's think about a line here which is imaginary because I am not able to hold it, right? So one is here, one is here. See one thing, right? If you pass a plane like this, even then it is not divided into equal half. If you pass a plane from this side, on the triangle side, even then these two are opposite, right? If you pass a plane like this, even then it's not possible, right? Okay. So if you see it here, it also depends upon whether what kind of condition you have, right? Okay. Now these two, one is below, one is above, right? If I pass a plane like here, it will not have. If I pass a plane from this side, between this, even then it will not have any POS. One will be above, one will be below, right? Wait a minute. If I pass a plane, this is a triangle, this is above, this is below. If I pass a plane here, right? Even then the POS, it's not like symmetrical position it is dividing into. Even then it's not possible. So here POS is not possible. No matter how much we try, we are not able to pass a plane which is having like symmetric here. In this case, you can easily pass a plane which divides this atom into equal half, and these two are divided one side and other side, right? That means here POS is definitely present. Here also POS is definitely present. Okay? Yes, no, yes. Right? Now let's talk about these things. On this carbon, definitely POS is present, because if you pass a plane that cuts it into equal half, then these two POS is present. Right? If you see this here, right, if you pass a plane that divides this bromine and this chlorine, and here it divides, basically these two things are divided into equal half. One chlorine is on this side, one chlorine is on this side, and it is passed like this, that on the same carbon, the bromine and chlorine are divided into equal half like this. Okay? So they are divided into equal half. So here also POS is present. What about this one? In this case, if you pass a plane which is like this, like parallel to this, you will break it into equal half, 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 and this whole will be sliced up into equal halves, right? So that means POS is here present. Right? Okay guys, do let me know if that is clear to all of you or not. Right? If you see this POS, this is not a plane of symmetry. This POS is not present. But if you pass a plane, not like this, but like this, right? But like this. So here what actually we are doing, this kind of situation it is. This kind of situation where you have two atoms here, when you divide, it's like this kind of situation. Actually this kind of situation. Okay? Right? Okay? Now this thing you have, when you pass a plane from here, this is divided into equal half, this is divided into equal half, this and this, all of them are divided into equal half, and this whole pentagon ring is also divided into two equal cuts we are dividing it into. Right? Or that's how the POS is present here. Tell me guys if that is clear to all of you or not. Right? Okay? Done? Yes students? No, there it will be POS will be present. POS will be present here. Right? Okay? Yes. POS will be present here. Right? Okay? If it is, wait a minute, this is, PS will not be present, so sorry, yes, I forgot the lining, lining, that means they are not in one plane, right, they are not under one plane, right, this may be, because this is a tetrahedral angle that it is forming, right, there will be angle strain here. So this is not going to be in one plane. Maybe this is solid, this is dash here, this is solid. First thing is this should be mentioned here whether it's solid or where, dash, what is there. Now if I pass this, even with this thing, one is like in front, like this is BR, this is CL. If I say this is my pentagonal ring, if I pass a plane from here, if two hydrogens are backward and one bromine and chlorine are in front, then I can't divide it into equal half. That means bromine and chlorine has to be on the same plane. In this case, so they are on the same plane only, right? They are on the same plane. But in this case, they are not on the same plane, right? So that means this is not present, no POS, okay? Yes, you were right, Abhishek, right? Okay? You were right. Okay, yes, you were right. I forgot about the planes there, right? The 3D diagram, right? So do these have POS? Now this is simple one, that this is what you need to understand. So POS is present here, OH, OH, H and CH2, so POS is present. In this case, POS is not present here. right? Okay, so let's talk about center of symmetry. Center of symmetry means from the center there will be a point. What you have to do, go forward, then go backward. Here you are seeing a line and here you can see a corner. That means this is not a center of symmetry. When forward and backward you have same thing, that will be COS, center of symmetry. If you see here, forward you will have a line, backward also you have a line. That is a center of symmetry. Forward you have a corner, backward also you have a corner. Forward you have a corner, backward also a corner. It's a line, right? So that is center of symmetry. Here, forward you have a corner, backward you have a line. Here you have a line, here you have a line, right? But here if you see, you have a corner, here you have a corner, here you have a corner, but that is different. Here you have a corner, that is different. So clearly we can see this is not a center where everything that you are getting is same. So that means every single point, center of symmetry means here if I go here also I'll get same, here also I'll get same, here also. Every single point that I travel, I'll get the same thing forward and backward. So here COS is not present, right? Here COS is present, because if I go here, I'll get the same thing. If I go here, I'll get the same thing. So same environment is observed whether you go forward or backward. That is called center of symmetry. Otherwise, this is not asked that much. It's just for, like, you know, your understanding. Now, chiral center is what is important for you. This is from where the questions are asked, right? POS, COS, I just you know, taught you for your understanding, right? So that you can start imagining things. This is from where the questions are directly asked, okay, right? Right, okay, yes. Now, chiral center, if you see, chiral center is a center which is sp3 hybridized and it has 4 different groups. That is a chiral center, okay. Let's talk about if any of them has chiral center, and these are the questions that they can directly ask you. Even calculation of optical isomer, calculation of stereoisomer is based on the chiral centers only, right? So let's understand this. Here you have 2 hydrogens, so it's not possible. Here 2 hydrogens, not possible. This carbon has chlorine, this group is different, this group is different, and here you will have 1 hydrogen. That means you have 4 different groups here, and this is sp3 also. So this is the chiral center that you will have. This is again, this is CH3, so not chiral. This is 2 hydrogens here, so not chiral. What about this one? Here this is sp2, so not possible, not possible. Here you have 2 hydrogen, 2 hydrogen, 2 hydrogen, not possible. This carbon is sp3 and this has 4 different groups. 1 bromine, 1 this CH2, 1 is this CH, that is this one is different, this one is different, okay, and then there will be 1 hydrogen, so this is a chiral center, right? What about this one? This is 2 hydrogens are present here, so it is not chiral. Here it is sp2, so this compound is achiral. This compound will be chiral, which has at least 1 chiral carbon or chiral center, right? Okay. Now let's talk about this one. Here we can see all of them have 2 hydrogen, but in this case, this has 1 chlorine, 1 hydrogen, CH2 same, CH2 same. So this is a chiral, because here this environment is same, this environment is same, so that means both the compounds are same, right? What about this one? This is 2 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen, so not possible. This carbon has 1 methyl, 1 this group, 1 this group. Now this group is different, this group is different. Why? Here you are getting CH2, here this is CH, CH3, CH2. So that means these 2 groups are different. and one will be hydrogen here. So that means this is chiral. Similarly, this is also chiral because this has one methyl, one this group, and one hydrogen. Okay, so this has two chiral compounds, two chiral centers. This one, this has two hydrogen, so chiral is not a possibility. Here two methyl groups which are same. You need to have 4 different groups on that center, so this is also not a possibility. Let's talk about this one. Here you have one methyl, you will have one hydrogen. This group is different, so it is chiral. This one also, this is ethyl, there will be one hydrogen here. This group is different, so we can say this is also chiral, right? Tell me guys, okay, if that is clear. What is chiral, achiral? Are you able to understand? Are you able to do that? Are you able to understand that? Are you able to do that? Let me know. Okay? Yes, everybody? Yes, everybody? Done? Okay? Yes. So, let's talk about next one. Here, you need to tell me which one is chiral, which one is not chiral. First thing is you should have sp3 hybridization. 1, 2, 3, 4 sigma, that means it is sp3. Here also it is 1, 2, 3, 4 sigma, it is sp3, right? Now this has two same bonds attached, that is double bond O, so this is achiral. Here you have attachment of double bond O and double bond S, so it will be chiral in nature, right? Because this has OH is different, CH3 is different, double bond S is different, double bond O is different. So this is going to be a chiral molecule. Okay? Where you are confused, tell me. Simple thing is you just have to see 4 different groups in sp3 hybridization, right? If you see this here, this is Et, this is one hydrogen. If you see here, just like you used to see in JEE, here you will have one CH, here also same. Here it is one CH, then methyl. Here you have one C, then 2 methyl. That means this environment is different, this environment is different. That's how I wrote it that this is chiral. Okay. Similarly here, right, you have one methyl, you have one hydrogen. If you see here, you have CH. If you see here, you have CH. If you go here, you will have 2 methyl. If you go here, you will have ethyl. That means the environment is different. So this is also chiral. Okay, tell me. It's kind of tricky. Can you solve this, ma'am? Darwin will do this in the end because this is the ending part of today's lecture, right? Okay, we'll do this in the end. Okay? Yes. Right, everybody? Let me know. Right? Let me know if that is clear. Acha. Now these two questions are very important, right? Very, very important for you. Because here what we actually see, we usually think that, okay ma'am, this is sigma, 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 and here you will have ma'am one lone pair, which is also another 3 sigma plus 1 lone pair, right? Ma'am, it is 4, so it is sp3, and all the 4 are different, so this will be chiral, right? Here also we discuss the same, that ma'am, we have one lone pair here, 1, 2, 3, 4, all the 4 groups are different, so this will also be chiral, right? Isn't it? This is what we think. Tell me. Everybody, let me know in the chat box, isn't it what you are thinking? Tell me everybody, isn't it what you are thinking, right? But here things will be quite different, because actually what will happen, this particular lone pair is actually in the delocalization. Lone pair, single bond, double bond. And I told you this in aromaticity as well. Whenever the lone pair is in the delocalization, that is not involved in the hybridization. So this will not be involved in the hybridization. So what we can say, because this is not involved in the hybridization, so we will say this is 1 sigma, 2 sigma, 3 sigma. So this nitrogen is going to be sp2 hybridized, and that is the reason this will be a chiral. That is the reason this is going to be a chiral here. Okay everyone, let me know if that is clear to all of you or not, right? Yes Uma, I'll teach, don't worry about that, I'll teach, right? Okay, yes. And let's make the likes by 50 plus, okay? Let's make the likes 50 plus, right? Let's make it 50 plus. Let's see if you can do that or not. Chalo. Okay, now guys, let's talk about meso compounds, some important definitions we have, right? What are meso compounds? Meso compounds are when you have two chiral centers, plane of symmetry is there, and it is also optically inactive compound. This is one of the students was saying in the comments, ma'am, there was a confusing question where I had two chiral centers also, plane of symmetry was also present. These are called meso compounds, and meso compounds are optically inactive compounds, right? So here, just like here, if you remember, we have did this here, okay? If you remember, we did this here. It had two chiral centers, okay? It had two chiral centers, right? So two chiral centers are there. These are the two chiral centers that are already there. If you see, POS is also present. POS is present. Two chiral centers are there, right? So can I say this is meso compound, right? What about this one? POS is present. This is also chiral. This is also chiral, because sp3 with 4 different groups, sp3 with 4 different groups, right? CH3 is different than this one, OH3 is different than all of them. So this is also same, POS is present and two chiral centers you have. That is meso. That is meso. Let me know. Yes, PDA will definitely be provided, okay? Don't worry about that. Guys, let me know in the chat box if that is clear or not. Right, everyone? Okay. Meso compound. Yes, it's a meso compound which is too sasta, right? So, that's a very good way of learning this. Meso compound, meso compound, right? Like meso is very different. You get everything for like, very good price, right? Here you get everything for very good price. You have POS, you have two chiral center, but still it is, right? Everyone is actually taking this, right? Okay. Now what is racemic mixture? This will, more about racemic mixture we'll study in haloalkanes, haloarenes. So whenever you have like SN1 mechanism, there is formation of a carbocation. Those who know this mechanism, they know that what I am talking about. If you have no idea about that, don't worry, we are going to study that in 12th class, and also in haloalkanes, haloarenes, I'll do that, right? If you are like in from 11th class, then we'll do that in 12th class, right? So carbocation, if you have that formation, from two sides it can attack. The nucleophile usually it is that attacks from two sides. That is the reason one attack can be forward, one attack can be backward, right? So that is the reason racemic products are formed. Racemic means where the 50% is where the configuration is same, it has retained, and where the configuration is inverted, right? Okay, so this is actually retention of configuration. This is inversion of configuration. More about this we'll talk about in our reaction part, right? As of now, you just remember that, okay, for example, this is a compound. Here you are replacing, let's say here earlier you had, let's say earlier you had here, just I'm taking random example here, here you have halogen, okay. Now with some reaction that we are not going to talk about in this lecture, right, with some reaction we substituted halogen with OH. So what can happen, either on the same position it can happen from where X left, on the same position OH can be there, this is retention. If it is on the opposite side, that is called inversion, right. And when you have a mixture which is retention and inversion both, that is called as racemic mixture, right, okay, that is called as racemic mixture, right. Now guys, let's talk about optically active and inactive compounds in allenes and spiro compounds and biphenyl. Very simple topic this is. So now 2-3 simple topics we are left with, okay. Let's do that. Okay everyone. SN2 inversion and retention both. In SN2 there is Walden inversion, in SN1 there is both inversion and retention, right. That we'll talk about in haloalkanes and haloarenes. In detail we'll talk about that, right. Okay, so now guys, understand what is allenes. Allenes are when you have double bond next to each other, right, adjacent double bonds you have. So what exactly happens here, right, double bond should be like this, first double bond, second double bond, but in reality they repel each other so much that their plane is different and perpendicular to each other, right. So if I say that you have 3 double bonds, C double bond, then double bond, then double bond, if this is in X plane, this will be in Y plane, this will be in X plane. Then if you have another double bond, that if you have something like this, then this will be again in Y plane, this will again be in X plane. That means all the planes will be perpendicular to each other, right? All the plane will be perpendicular to each other. That's how they are going to look like. These are allenes, right? Now, a simple trick first thing is, because they are perpendicular to each other guys, if I am talking about that this is the plane, okay. If this is on the X plane, this is on one plane, then that means this is going to be on a different plane, right. So whenever you have even number of double bonds, this will be on same plane, then these two will be on forward and backward. Like means if this is on one plane, one will be forward and one will be backward, right, like this, right. One will be forward and one will be backward like this, okay. If this one, this Cl and we are on the same plane, then these two are going to be forward and backward, okay. That you should remember. Now see, one thing is, either you can firstly imagine that POS will present, this thing will happen or not, either you can imagine all of that, right. Or in allenes, what we will simply do is just remember this particular part here. Just remember this, and trust me, most of your questions, 100% you will answer it correctly. If you have odd number of double bonds, then this is inactive compound, right. Odd number of double bonds means it is an inactive compound. If you have even number of double bonds, that in that case, if different substituent on one carbon, only then it is active, otherwise it is inactive compound. That means the overall situation is, first thing, you should have even number of double bonds. Second is, you should have on both the ending carbons, you should have different substituents, okay. Only then it is active, otherwise it's inactive, right. Let's see this here. These are even number, right. These are even numbers, and on this carbon you have two different substituents. On this carbon you have two different substituents, so this is going to be active. This is going to be optically active, okay, right, okay. Yes, Vivan, okay, got it. Now let's talk about this one. If you see this, How many double bonds? 1, 2, 3, 4. 4 double bonds means you have to check whether on the last 2 carbons you have same or different. So on this carbon you have same substituent. So even and same substituent, that means it is inactive in nature. It is optically inactive compound. So directly you will answer it like this. Okay, understood? Directly you will answer. So optically inactive. Next is you have 3 carbons. Wait a minute, 3 now. Here 3 means X, Y, X. So that will be on the same side only. That will be on the same side only. Right? Same plane they will be in. Right? Okay. So now here what you will have? Odd number, and odd is always optically inactive. Odd is always optically inactive. Right? Odd is always optically inactive. Right, everybody? Acha. Now one very, very important part here, that is, if you see this here, wait a minute. Yes, I told you that for optically active there should be no symmetry here, right? This we have discussed. Now see this thing. If there is odd, why it is always optically inactive? Because in odd they are always on the same plane. If they are always on the same plane, there will always be a plane that will cut it into equal half, right? If you have on the same, this phone is on the same plane, okay? So there will always be a plane. This way I can't cut it into equal half because camera portion will be here and rest of it will be here. If I cut it like this, right, like this, so when it is on the same plane, there is always one plane that is cutting it into equal half. That's why it is always inactive. Right? Okay. Yes, everybody. So, next we have is spiro compounds. In spiro compounds, replace double bond with these rings. Okay. Everything else is same. If you have 2, see, just like in double bonds, the plane is perpendicular. Even in spiro, if you have 2 spiro, these are also perpendicular. If this lies in x-axis, this will lie in y-axis, right? So here, if you have even number, you will see whether on the last carbon you have different substituent. These are different substituents, so that means it is optically active in nature. So here you will say this is optically active in nature, right? Okay. Next is, here you have odd number. You have 3 rings. So odd number is always optically inactive in nature. Odd number is always optically, you don't have to see whether there is same on the same carbon or different. So optically inactive. Okay. Yes, everybody, do let me know if that is clear to all of you or not. Right? Okay. Yes. Now biphenyl. Now biphenyl means you will have 2 phenyls connected to each other, right? Now biphenyl usually is on the same plane, but if you have very large group that is present, see, one thing is, if you have very small groups present, if small groups, then always it is inactive. Because small groups means they are always going to be in same plane. If it is on the same plane, there will always be a plane that is POS. Okay? But here, if you have large groups like these, so the plane will become perpendicular to each other, right? Now, if you have large groups, then you will have to see, if you have large group, they are perpendicular. Planes are perpendicular. Plane are perpendicular. That is the reason you will have to see same means inactive. Same means inactive. If you have different substituent, that means it is active. And here we are talking about the sides. If on the same side you have different substituent, here also you have different substituent, that means it is optically active compound. Okay, guys, do let me know if that is clear to all of you or not, right? Do let me know everybody if that is clear to all of you or not. Right everyone? Yes. Right everybody, do let me know, everyone here, everyone, right? Okay. Rest of the students are sleeping or what? Huh? What you're doing guys? Sleeping, is it? So next is this one, right? Big groups you have here, you have to see whether on same side you have different, this is different. But here you have same. On this side you have same. That means it will become optically inactive compound, right? So this was about spiro, allenes and biphenyls, how you're going to see the active and inactive compounds here, right? Okay. Now the last part of today's lecture, that is calculation of optical isomers, calculation of stereoisomers. Right, calculation of optical isomers and calculation of stereoisomers. Ready everybody? Ready? Ready to do calculation of optical and stereoisomers. Okay, let's start with that. Okay, the formulas can get very confusing, right? I'm bluntly telling you, but stereoisomers are directly asked, so it's very important, right? Okay, it's very important. So first is what is, now one of the students was saying, ma'am, they asked me about mesoisomer also, like these also. This is based on this formula, okay? So if it is an unsymmetrical compound, here optically active isomers will be 2 raised to power n, right? There is no optically inactive isomer, that means meso will be 0 here, right? Okay, meso is going to be 0 here, right? For a symmetrical, if it is even, then it will be 2 raised to power n minus 1. If it is meso, it will be 2 raised to power n by 2 minus 1. Okay, if it is symmetrical and the number of optically active sites, that this n means the number of chiral carbon. Number of chiral carbon. This n simply means, just like in calculation of GI, n means number of GI sites. Here n means number of chiral carbon, chiral centers. Okay. This is 2 raised to power n minus 1 minus 2 raised to power n minus 1 by 2. Right. And here meso is 2 raised to power n minus 1 by 2. That is how you are going to calculate, and optical isomers are optically active plus meso. Racemic mixture or enantiomer are optically active by 2. Once you calculate optically active and meso isomers, right, then if you add them, you will get total optical isomers. And if you are talking about enantiomer or racemic mixture, that is equals to optically active divided by 2. Okay, so these are the formulas, and that is the tough part here. You have to remember that, right? Okay, if you see this here, this is how to calculate number of optical isomers, right? So this is chiral, we know. This is also chiral, right? Bromine, hydrogen, this, no, actually, wait a minute. Yes, this is, these two are chiral. Yes, yes. Okay, these two are chiral, because this one is different. Here you are getting bromine, and on this position you are getting chlorine, right? In this case, with this carbon you are getting bromine. In this case you are getting chlorine, right? So both are chiral centers. So that means n is equals to 2 here, right? Is this a asymmetrical or what kind of compound? Is this symmetrical? Does it have any plane of symmetry here, right? No, this is asymmetrical. This is asymmetrical. So whenever you have asymmetrical, right? So this plane, if you pass, this is not divided into equal halves. So this is not a symmetrical molecule. That is the reason here optically active, if I define, optically active is going to be 2 raised to power n, yes, okay. optically active will be 2 raised to power n, that is 2 raised to power 2, that is 4. And meso is going to be 0 here. Okay, meso is going to be 0 here because there is no plane of symmetry here. In asymmetrical, no POS is there, that's why it is going to be, meso is going to be 0, because for meso you need to have a plane of symmetry, right? Now in this case, if you see, you have a POS, these are two chiral, wait a minute, if you see chiral, this is bromine, this is hydrogen, here you have different, here you have different, okay. If this is hydrogen, this is bromine, here you have different, here you have different. That means you have two chiral carbons, right? You have two chiral carbons, so we can say that N will be equals to 2, right? Okay. If N is equals to 2, in that case, it is symmetrical or asymmetrical? Isn't it symmetrical? Yes, ma'am, right? POS is present here if you see. POS is present. Now in case of symmetrical, if N is even, it will be 2 raised to power N minus 1. Okay. So here answer will be 2 raised to power, optically active will be 2 raised to power N minus 1, that is 2 raised to power 2 minus 1, that is 2. And meso will be 2 raised to power N by 2 minus 1, that is 2 raised to power 2 by 2 is 1 minus 1, that is 1. So total optical isomers will be optically active plus meso, that is going to be 2 plus 1, that is 3. And racemic mixture, that means enantiomer is going to be, racemic mixture and enantiomers are same only, that we will discuss in haloalkanes, haloarenes. Right, racemic mixture is optically active 2 by 2, that is 1. So racemic mixture will be 1 here. Right, okay. I am going to create my own formula. They will also give you their own marks then, right? Okay, tell me everybody if that is clear or not. If this thing is clear to all of you, do let me know in the chat box. Do let me know in the chat box, everyone. Right, we are almost towards the end of this chapter, this particular session. Right, now here you need to see one thing. There is a thing called pseudo-chiral, right? Pseudo-chiral is if between two chiral carbons, and it is also symmetrical. In pseudo-chiral, the condition is the molecule has to be symmetrical. It has to be between two chiral carbon or two double bond, right? Okay. Actually, what is defined here, when you talk about a chiral carbon, no, we define R and S configuration that we will see in the next lecture, right? So for each chiral carbon, we define R and S configuration. That means this can be R or this can be S. This also can be R or this can be S. Right? Now, if it becomes R and R, this will not be chiral. If it becomes S and S, this will not be chiral. But what if it becomes R and this becomes S? What if this becomes S and this becomes R? Then it is going to be chiral. Right? So that is why this particular is called as pseudo-chiral. Right? And ma'am, how can we calculate the R and S configuration? That we'll talk about in the next class, that why we can't calculate. Actually, for R and S configuration, you need to see whether H is here or H is here. Whether it's OH and H or it's OH and H. From that, you need to see that where is H, where is OH. From that only you can tell R and S configuration. Because here you can't tell that. So it can be R, it can be S. So that is why there is this confusion whether this can be chiral, this cannot be chiral, depending upon these cases. So that is why this is called as pseudo-chiral. Okay, that is why this is called as pseudo-chiral, right? Now this is one thing of pseudo-chiral. Another a possibility of pseudo-chirals, you have a carbon between two double bonds, right? Okay, between two double bonds, let's say this is CH3, right? Now here what happens, this can be cis or trans. Now that also, cis and trans is also defined by whether they are opposite to each other or on the same side, right? So they are also defined like that. For example, here you will have this hydrogen also, this also will have hydrogen, this also will have hydrogen, this will have H2. Now this can be cis or trans, this also can be cis or trans, right? Now if both are cis, then this is not chiral because both substituents are same. If both are trans, this is not chiral. If this is cis, this is trans, this will be chiral. If this is trans, this is cis, this will be chiral. So this condition is also of pseudo-chirality. So these are the two conditions in which you will have pseudo-chiral carbon. Okay, this can be pseudo-chiral and this will be pseudo-chiral. Okay, these are the two pseudo-chiral that you will have, right? So what I told you about pseudo-chiral, two chiral carbons or between two double bonds, if you have a CH2OH group or a carbon, right, then that will be called as pseudo-chiral. Okay, yes everybody, let me know if that is clear to all of you or not. Pseudo-chiral we have done, right? Okay, pseudo-chiral we have done. Now if you see this here, this is a pseudo-chiral. So here number of chiral center is going to be 3. 1, 2 and 3. Usually we write 2, but here it is 3. Now usually students miss on this one. Why? Because how is it possible? But because of this differentiating like pseudo-chiral thing, it was glucose, right? So because of this thing, if you thought this was glucose, then your biomolecule is very weak, right? So N is equals to 3 here, right? Now here this is symmetrical also, right? This is symmetrical also. So here N is odd, right? When N is odd, then what is the formula that you have here? 2 raised to power n minus 1 minus 2 raised to power n minus 1 by 2. Okay, let's do that. 2 raised to power n minus 1 minus 2 raised to power n minus 1 by 2. I hope so. This was, now this, so I really doubt that they will ask you this one, but you never know, right? So optically active isomers will be, right? This will be 3 minus 1 is 2, this will be 3 minus 1, that is 2 by 2, that is 1. So it will be 4 minus 2, it will be 2. So optically active isomers is going to be 2. What about meso compounds? Meso will be 2 raised to power this particular part. Meso will be 2 raised to power 2 by 2, that is 2. Okay, so total optical isomers will be 2 plus 2, that is 4. Optical isomers, right? These are active, these meso are inactive, right? And racemic mixture is going to be optically active by 2, that is 1. Okay. Yes, everybody, do let me know if that is clear or not, right? My throat is little blocked, that's why I'm speaking so slowly. Acha, tell me, is that clear everyone? Last is calculation of stereoisomers, right? Last is calculation of stereo, and from this, like literally so many questions, like mostly questions are asked from either geometrical isomer calculation or stereoisomer calculation. Optical isomer I think is on a little difficult, the formula is little on the difficult side, so that's why they are not asking that, but they can, right? So asymmetrical, it is 2 raised, I know you are literally thinking that ma'am please, if they give us asymmetrical compound, that's great. If they give us symmetrical, will burn out, right? So asymmetrical is 2 raised to power n, and symmetrical is 2 raised to power n minus 1, 2 raised to power p. And what is p? P will be n by 2 minus 1, or it will be n minus 1 by 2 depending upon what you have, right? Okay. Now, if you see this here, stereoisomer here is going to be, wait a minute, yes, okay. So in this case what you will have, everyone, so this is going to be, firstly you have to calculate the stereo. Stereo means n is going to be number of GI sites plus chiral center. Both you will calculate in the stereoisomers, right? Both you will calculate. Here this is not, this, different, yes. This will be chiral. This different, this will be chiral. This different, this will be chiral. So number of chiral is 3, and for asymmetrical, right, it is going to be stereoisomers is going to be 2 raised to power n, that is 2 raised to power 3, that is 8. But remember one thing here, that in this case GI is 0. So stereoisomer is equals to optical isomer only, right? Here GI is 0. There is no GI here, right? There is no double bond here, right? So GI is going to be 0 here, right? Okay, what about this one? If you see this here, guys, right, you have to see GI sites also. Firstly, this is the double bond, that is H and CH3 is different, H and this whole group is different, so this is a GI site. This is a chiral center. So that means number of stereoisomer site is 2. One is GI, one is chiral center, right? And this is a asymmetrical carbon, asymmetrical. So in case of asymmetrical, what you have, P will be, if it is even, it will be n by 2 minus 1, okay? P is equals to n by 2 minus 1, that is 2 by 2 minus 1, 1 minus 1, that is 0, okay? And the formula is 2 raised to power n minus 1, 2 raised to power p. 2 raised to power n minus 1, this is 2 raised to power p. So it is going to be 2 raised to power n minus 1 is what? N minus 1 is 2 minus 1, this is 2 raised to power 0. So this is 2 raised to power 1, this is 1. So this is going to be 3. So total what you have, 3 things. 3 stereoisomers you will have in total. Okay everyone? 3 stereoisomers you will have in total. These I am talking about stereoisomers. That is optical plus GI. Okay? That's how you are going to calculate it. Now what about this one? If you see, this is a site of GI, H and this group is different, H and this group is different. This is a site of GI. This is a chiral carbon because H, C2H5, CH3 and this is different. This is a site of chiral carbon because all the groups are different, right? So we can say N is equals to 2 plus 1. 2 is chiral, 1 is GI, so it is going to be 3, right? This is a symmetrical molecule, right? In the symmetrical molecule, again what we will see in, wait a minute, asymmetrical it was, na? Then why we have done all of this? This was asymmetrical, so directly we could have calculated. My mistake, right? Asymmetrical, so directly we could have calculated this. Asymmetrical was simple, 2 raised to power 2, that is 4. So here it will be 4 stereoisomers, okay? See how things, change with one single mistake. So symmetrical, means and you have odd, n is odd. So if n is odd, it will be p is equals to n minus 1 by 2. That is 3 minus 1 by 2. That is 2 by 2. That is 1. Right? And here stereoisomers will be 2 raised power n by 1 plus 2 raised power p. Right? So n minus 1 is 2 raised power n minus 1. 3 minus 1 is 2. This is 2 raised to power p, here it is 0. Right? So it will be 2 to 4 plus 1, that is 5. So here total answer will be 5 stereo isomer. Yes, it was 4, it was 4. In this case, it was 4 because it was symmetrical. 2 raised to power 2 is 4. Okay? Symmetrical. If it is symmetrical, then we will use this formula. That is, if it is odd, it will be p is equals to n minus 1 by 2. 3 minus 1 by 2 is 2 by 2, which is p is equals to 1. So 2 raised to power n minus 1 plus 2 raised to power p. And this is the answer that you are going to have. Let me know, guys, if that is clear to all of you or not. Last topic of today, that is stereo center, right? What is stereo center? What is n? We were defining n in that formula. What is n? N in that formula is number of GI sites plus chiral carbon, right? But stereo center, we will take, here we have taken it as one GI site, but centers are 2. So here center is 2 plus 2, that is 4. So in this case, stereo center is 4, right? If you talk about this one, GI site is 1, but in that one GI site, it is 2 centers. So stereo center is 1, 2, 3. That means 2 into GI site plus chiral carbon, that is 3. That's how you're going to define the stereo center, right? If I want to write the stereo center here, it will be symmetry. Let's calculate everything here. Let's calculate number of stereoisomer, number of GI sites, everything. So this double bond, if you see, this is hydrogen, this is hydrogen, this is not a GI site, okay? This double bond is a GI site, right? So GI site is 1, okay? This is the chiral carbon, Cl is different, H is different, this is different, this is different. This here 1, 1, 2, 2, these are different, this is also different, this is also chiral carbon, right? There are 2 chiral carbons here, right? So chiral carbon is 2. So if you talk about stereo site, stereo center, it is number of GI site multiplied by 2 plus chiral, that is 4. 1, 2, 3, 4. But number of stereoisomer sites, not stereo center, sites, is 2 plus 1, that is 3. Okay. So for asymmetrical, because this is asymmetrical, stereoisomers are going to be 2 raised to power n, that is 8. And that is how you are going to define it. Okay, everyone, do let me know. Ma'am, P is 1. Wait a minute. Where I have done mistake. 2 raised to power. Acha, this is 1. Yes. Very good, huh? Very good. Huh. This is 2 raised to power 1. P is coming out to be 1. So it will be 2 raised to power 2. This is 2. Yes, this will be 6. Okay? Yes. 4 plus 2, 6. Yes. 4 plus 2 is definitely 6. Okay? Tell me. Is that clear, everybody? Do let me know in the chat box if there is any problem so that we can do some PYQs here. 2-3 PYQs we'll discuss and then the session is going to end. Right? Let's see what kind of questions they are asking you. Let's see what kind of questions they are asking you. Which of the following molecules do not show stereoisomerism? Stereoisomerism is not shown by which of the following molecules, right? You need to see which will not have even a single double bond, which shows GI, or it does not have any chiral center. So one by one we'll make each of the compound. This compound shows one chiral center, so it will show stereoisomer. This has one double bond, which is definitely showing stereoisomerism, right? Okay, wait a minute. This is H, this is C2H5, C2H, no. This and this group is same. So GI is not possible. Stereoisomer is also not possible, no chiral center. So this will not show GI here. This will not show any stereoisomer, right? Let's talk about the other compounds. This has GI, this exists. This has chiral center, so this also shows stereoisomer, right? So that means this is the only site which does not have any GI, or it does not have any stereoisomer, or it does not have any optical isomer or any chiral center. Basically, for stereo center, you should have either GI site or optical site. That means chiral center you should have, right? Either of them will work. Wait a minute. No, it will be 2, है ना? It is which one? 3-ethyl hexene, 3-ethyl hexene. Okay. 3-ethyl hexene is this one, not that one, right? So answer will be C is the correct answer. The options are incorrectly written. This is A, this is C. Okay? So 3-ethyl hexene is not going to show any optical any stereoisomer. Next question is, how many different stereoisomers are possible for the given molecule? If you see this here, this double bond will give you GI site, right? Stereoisomers they are asking you, this is going to show chiral center, right? So number n will be 2, one is GI, one is chiral, and it is a asymmetrical molecule, and this was asked in 2025, right? So that means it will be stereoisomer will be 2 raised to power n, that will be 2 raised to power 2, that is 4, right? Optical isomer also will be 2 raised to power n, and optical isomer site is here 1, so optical isomer will be 2 here, and GI will be 2. Why? Because number of GI site is 1, so 2 raised to power 1 is 2, right? So you can answer any of it. So here answer is going to be 4 is the correct answer, and this was asked in your 2025 exam, and that was such a simple question that they have asked, right? Now this is another question that is for your homework, right? I'll just draw the structure and you'll have to tell me which is the correct option out of them. This is for homework. The number of stereoisomers for cyclopropane, right? 1, 2. That means 1 on second position you have CH3, right? Now you have to tell how many stereoisomers are possible in this case, right? Okay, everybody. 1, 4, 2, 3. That is your homework, right? That is your homework, right, everybody? Santosh, that I seriously, even I don't know, right? That's not in my hands, right? So what you can do is you can watch my lectures here, right? Because obviously your content will be covered here, so don't worry about that, right? Okay? Okay then students, now that's it for today, and take the screenshot of this one and answer it in the comment section, your homework, right? And I really expect you guys to do that. And before going guys, this is our MVSAT scholarship program, which is registration is completely free of cost. Just 10 days are left here, right? All these things, if you're getting AIR between like among 2.5 lakh students, then you will get 100% scholarship, right? You will get 2 crore worth of prizes and rewards like iPhone, iPads, drones, etc. and 150 crore worth of scholarship you will get for totally free of cost. Everything What you have to do, register yourself, and that is also totally free of cost, right? So guys, that's it for today, and I want you guys to write it down in the comment section, your homework, right? So let's see how many of you do that. Okay, yes. Okay then guys, now I'll see you all in the next class, that is tomorrow, for conformers of alkanes, RS, DL configuration, and I'll also discuss rearrangement of carbocation there only, right? Which is a very important topic, so I don't want to separately discuss that because it's a very small topic. So I'll discuss rearrangement of carbocation in the next class, that is tomorrow itself, right? Okay then students, bye bye, and I'll see you all in the next class. Bye bye, take care.